Okay, let's get started. This is the Sausage Sports Club weekly update, where I talk about progress this week, how I'm feeling about the game, and all of that. As usual, I like to start by saying why I like to do this. There's 3 reasons. One, I think it's useful for new developers or people interested in getting into indie games from like AAA development to see how a solo game gets made over time and what that does to a person, and just to get insight into my process and see like, is there anything you can learn from what I'm doing to help you. The other obvious reason is like marketing help. If I don't talk about the game, no one's gonna know what it is, so I gotta do that. And then third is a selfish reason. When I look back on this game in 5-10 years, I think it's going to be interesting to see what I was doing now versus what I'm doing then, if I've gotten better, if I've learned by making games, and hopefully I have. And if not, then I'll be able to see, oh, I was much better at making games on Sausage Sports Club. Maybe I can learn something from that. So that's the idea. Today, we're going to talk about the finished hats that I talked about last week and that I've been working on for a while. I made 40 hats or 41 hats or something, and it took about a week and a half from conception of all the hats to like modeling and texturing and setting them up on all the characters and setting up all the physics on them and stuff. So I'm going to show you the finished product and talk about the physics, how that stuff works. I'm also going to talk about a little bit more optimization that I did this week, and go into some detail there. I'm also going to show like what the profiler looks like and how I use that. I feel like the way I use it is pretty standard, but it's still going to be useful to show. And then last, I'm going to talk about tips for preparing your game for conventions. I talked about this on Twitter a little bit today. I helped not run, I didn't organize the event, but I was like there for setup, and I set up games and I did teardown and stuff. I was like a volunteer captain or whatever. But so as I was setting up these games and having gone to like a bunch of conventions to show Sausage Sports Club, I realized that there's a bunch of stuff that especially new game developers don't know about conventions, and they don't know what can go wrong at conventions, especially something like BitBash, where not all of the developers of the different games are there, and you can just send I can send like a build to BitBash and they'll do it. They'll set it up for me and run my game for me. But there's a lot of things you can do as a developer to make it easy for places like BitBash to show your game. And I feel like a lot of people don't know that, and so they go to something like PAX or they send their game to BitBash, and they just have to like learn those lessons by going a lot and just like failing a lot. So I've had a good amount of experience doing that, so I'll share that stuff with you all. I should probably open the Twitch chat. I'm going to do that really quick before I start. Okay. Pop out. Okay, cool. Okay, so let's get into it. Shit. There we go. Okay, so I'll just load up the Overworld and I'll spawn in my dude with a hat. And then I have like a keybind to just like shift between hats really quick. I'm not gonna do any bots. Let's do demo, release. Overworld. Don't do that. Okay. Just gonna load up quick. Cool. dude. He does not have a hat. What's the deal there? Looks like I messed something up. That's good. Good start. I don't really understand how I could mess up hats. That's annoying. Let's see if it works on the bots. That's annoying. Give this one more minute, see if I can fix it, and then I will move on. Let's kill the last bot. Sorry for the rough start here. One of the optimizations I'm going to talk about is related to this, I assume is related to this hat issue. Something I discovered about Unity recently is if you have a really deep hierarchy of game objects, let's say like under one root game object you have like 300 child objects. If you move the parentmost object, all the ones beneath it need to be updated, like their transforms need to be updated to reflect that change you've made. But what I would expect is if the game objects, if those children game objects are set inactive, that the cost of updating the parent transform would go down, like it wouldn't reflect the inactive objects, but it turns out that it is reflected. And so with the characters and their hats, the way that works is all of the hats like start as children of the character game object, and then I move them to a separate like cache of hats, so that whenever the player moves, the hats don't get moved and they don't have to be updated, because there's 60 hats. A lot of them have like one or two child game objects, like the snorkel has like the snorkel mouthpiece, or the beard has like the mustache piece, and any of the rigged hats, like Santa hat is like a rigged skinned mesh. Those have like several game objects because a rigged mesh has like a bunch of stuff under it. So that was ending up adding like maybe over 100 game objects to the parent hierarchy, which was adding a lot of time when I would move the characters or rotate them, just to like literally just to multiply like major C's together to update where the hats were supposed to be, even though they were inactive, even though they weren't like being rendered and you didn't need to move them. And that's a Unity thing. I need to fix this. object. Let's do so we're in the player. Let's see if that fixes it. Fingers crossed. Hey, we got it. Cool. Okay, so I have a keybind that lets me swap between hats, I believe. But I'm in release mode, so that doesn't work. I think that's why that doesn't work. Okay, cool. Okay, now we can look at hats. That was a long, arduous intro. So I'll try to go quick through these. Got a beret, bike helmet, boater hat. There's a bonnet. That was like an Irish cap, captain's hat. This is a Cavalier hat based on a backer request to make a hat that references like the Cleveland Cavaliers team colors. Cheese hat, chef hat, chicken hat, which is another backer hat, who sent me a picture of their favorite knit chicken hat, which I thought was cute. Construction hat, cowboy hat, crown. This is like a Davy Crockett skinned raccoon hat, devil horns. It's a director hat. This is another backer hat from Russ Pitts. And this was a reference to him being a director, and he sent me a picture of himself with his hat and headphones, which I assume he uses when he edits. This is like a soda drinking hat. Emo hair. Don't mind the editing or don't mind the jiggering of the character's legs. That's a bug that will be fixed very soon. It was part of me improving the animation transition between running and nope, don't do that now. Between running and stopping, and I didn't quite finish it. I had to move on to something else, so I just kind of let it stay. Fedora, fez, mermaid fins is what I would call these. Is another backer hat from Matthew DeLucas, I believe. We got a fish, flops around. It's a little hard to see. I guess I'll maximize. Got a flower pot, football helmet's classic. Fruit hat, like jiggly fruit. Visor, hair rollers is another bagger hat. My friend Will Kane. We got Halo with new flops. The old version of the Halo. Hot dog, jack-o'-lantern, karate helmet, medical mask, miner helmet, which I have some cool ideas for in the final game for this light, which I won't spoil right now. Motorcycle helmet. I'm calling this one a musketeer helmet, because that's the closest thing I could think of. Mustache and beard. I think the flop on this one could use some improvements. Neck brace. Paper hat. Head funnel. Looks like this one needs to be adjusted a bit. It's kind of like bleeding through the back of Scout's head. Pirate helmet plunger. There's another backer hat for my brother Justin. Elvis hat, or Elvis pompadour, I guess. Pumpkin, sunglasses, safari hat, Santa hat. Got some flops there. This one's a scarf. This one also looks like it needs to be adjusted. Bleeding through Scout a little bit. I think the flops on this one are also not perfect yet. You kind of make it go through the body a little bit. Scuba gear is a Sherlock cap, or like a paperboy cap, as John noticed. Sombrero, recently added some flops to this, probably could get a little better. You can kind of see the left side will like flop down way farther than the middle when I'm doing this. Looks weird. Astronaut helmet, top hat, added some new flops to that guy. We got turban, Viking helmet, VR headset, that one's pretty silly, and witch hat with new flops on it. Oh, and I skipped a few, I think. Bucket, Admiral, Afro, is it Barbu? It looks like this one also needs to be adjusted a little bit. So those are the new hats. You saw some physics. We'll talk about that in a second. Thanks, Spastic Chawa. Welcome to Singleton as well. Yeah, I hate that pop-up when that pop-up happens. Yeah, so let me show you. Those few hats that look super weird are a good motivator for me to show you how I set up the hats. Here's my little setup area over here. So you can see I just kind of like pile up all the hats in a pile, and in the game there's going to be some kind of, I haven't decided how exactly this is going to work, but there's going to be some kind of rarity system so that you're more likely to unlock hats that I rank worse or less interesting, and then it's going to be more rare that you unlock cool hats like the chicken hat or the neck brace or the flower pot and stuff. So that's cool. Let's fix up some of Scout's hats real quick. So it may not be obvious, but I didn't show you the other characters, but all the characters' hats are placed like slightly differently because their heads are shaped slightly differently. Even more so in the case of Omnibus. So I have to manually set up all these hats, and there's 60 hats and 11 characters, so that's 660 hats total. I just set them all manually. So I built a little tool, hat editor, that lets me specify where I want to be, and there's little buttons, and there's also like keybinds, so I can like shift through them really quick. So I remember the Barbu looked kind of weird. Interestingly, I can't see it here. That's strange. But I'll just scale that up. Let's find another one that looked weird. The football helmet maybe looked a little bit weird. No, it looked fine. Does chat remember another hat that looks strange? Can't seem to remember. Funnel? It's interesting that the funnel's like bleeding through the neck in here, but it wasn't in game. Curious what's up with that. And then there's one more that looked messed up, I believe. Well, anyway, this is the tool I use to set up hats, and I think it's pretty useful. Yeah, Trawa, I'm actually gonna switch to that right now, to showing you how this stuff works. So, like I mentioned, a lot of the hats are jiggly. And those are all skinned meshes. So those are the ones that I rigged in Maya, and that just means that I set up like a joint skeleton, much like a rigged character in a game. And I had to paint the skin weights so that the verts along the mesh know which joints to be associated with and how much. So you can see this pompadour. If I rotate this, it'll like rotate the thing. That's the base. So yeah, that's the base of it. And then the real magic is thanks to this asset dynamic bone, which is from the asset store. I guess I'll show the asset store version real quick. So I have this tab open already, I guess. So it's $20 on the asset store. It's of many assets I've used, this one was one of the easiest to set up, and although some of the tweakables they give you you can see on the right here, there's a bunch of them, and some aspects aren't super intuitive. If you just like hover your mouse over each of the different things, I found it was pretty easy from that to like intuit what things did, and then I could like test the hypothesis and figure out like, okay, this is what this does, or this isn't what it does exactly, but you know, I can figure out from there. So I use dynamic bone, and what this component does is it takes the joint you mark as root, which is, for me, this pomp joint 1, which if I rotate it, you can see it like doesn't rotate the base, it just rotates like the start of the I don't know what you call that, the foof. It takes that joint and then all of its children, and then turns that into like a joint chain, and then applies fake physics to it based on these settings that I set up on the right. And it's not real physics. It's not using the physics system at all. It's just using math to kind of based on the movement per frame, or if you want to use update, you can use update, or you can use fixed update, or you know, an unscale update. But based on that last frame, it takes like how much have we moved, how much have we rotated, and then it says based on that amount of movement, based on that vector of movement and that like vector of rotation, and based on all these settings we've set, let's rotate each of our joints to match that. So that's how it works. It's been interesting for me to use as a programmer, because I didn't like look into this very deeply. I haven't looked through all the math and like walked through it and learned fully how it all works. And so I've approached it as a designer, and that's been like an interesting experience making this game, because everything else is really like really just like from code that I wrote, and I intimately understand all of it. And this has been kind of like a nice break, or nice kind of like low-hanging free fruit to just like make the game a lot better without having to do crazy math work. So I'll go through these settings just to show you what I mean. I guess the way I'll do that is I'll start the game with a hat on. I'll use the pompadours because it's like pretty big and obvious. And then I'll like walk through and explain each of them, and you'll see how it's changing, how the pompadour moves. Yeah, glad to help. Let me know if you have any questions also as I'm going. Okay. Yeah, it always annoys me when the feet jigger around. Okay. Day is 0. Look at that jiggery boy. Okay. I'm actually going to plug in my controller so that I can still jiggle around while I'm in the scene view. so he's out of that junk. Okay. Kinda gotta put myself where the real camera is so that I know how the body's gonna react. There we go. Okay. So you can see that this like flops as you expect a pompadour to flop. It feels like secondary motion, like it slowly moves to catch up, and then it bounces a little bit, but not a ton. If we go into the settings of this guy, here are the different settings. I'm gonna ignore update, because it's not really important to the to the physics part of it. Damping, the idea of damping is how much is the movement of these joints, movement and rotation, how much are those slowed over time. 0.25 seems to be, it slows down by 25% every frame. Elasticity, as it looks like the tooltip's not going to pop up in game. This is how much force is applied to return my joint to its intended orientation, which is where it's at now. So if I move over to the right, the pompadour is going to fall behind, and we need to know how much it's going to like swing back, how fast it's going to swing back to match up. Stiffness is how much is it going to fall behind when I move. So if this is set to 1, it's going to not try to catch up at all, or it's not going to fall behind at all. Inertness is similar to stiffness, but it's only for movement and not for rotation. So stiffness is both rotation and position. Inertness is only position. So I believe if I set stiffness to 0 and inertness to 1, it doesn't do rotation, it just does position of the joints. Or sorry, it just does rotation of the joints, it doesn't do position. If I move that down. Yeah, that makes sense. Okay. Other stuff. Radius. If I turn up radius, you'll see these white circles will get bigger. So when I mentioned before, yeah, I'll come back to the dust particles. Yeah, I'll come back to the dust particles. So this radius and these spheres are used in a fake version of a physics simulation that Dynamic Bone uses. Like I mentioned, it doesn't actually buy into physics, the physics system that Unity uses, but it's got a fake built-in one that you can use. If we skip down a little bit, you'll see there's like a collider drop down, and I can define fake colliders that Dynamic Bone adds. And if I add that here, then that'll incorporate that fake physics simulation into the calculation of where the pompadour can fall. So if I look at the spine here, or sorry, the head collider, I guess, I can move this. I can move this over a little bit just so you can see it. This is a Dynamic Bone collider, and it represented by these yellow spheres, and you can see it looks kind of like a capsule, but the gizmo isn't represented as a capsule, it's represented as 2 spheres. But it works like a capsule would work, where you can define the direction of it, and you can define the radius of it, and you can define the height of it. Yeah, so I use this on all the characters. It's just like the same shape and size. It basically works as the same capsule as the player's head. And that's for something like the bike helmet, which I'm not going to switch to, but the bike helmet has these tassels on the side, like a bike helmet that's unclasped, And without this collision stuff, the bike helmet tassels like go into the player's head and it looks weird. But once you turn it on, they kind of like pop out and flop on the outside, which is what you want. So that's a cool built-in feature of dynamic bone. Exclusions is to exclude within your joint chain a specific joint or series of joints. So let's say I had what's a good way to explain it? Like let's say I had like a scarecrow that I wanted to move with the joint thing. That's kind of a weird example, but let's say my scarecrow is rigged like a person, where it starts at the hips and moves up the chest and then branches off into the arms and branches off into the head. Let's say we want our scarecrow to look attached to a post, so we want its like head to be nailed to the post, but we want the rest of its body to like wiggle around. This is a weird example, but just go with me. If we put dynamic bone on the hips and then we excluded the like head joint, the first neck joint or whatever, that would allow the rest of the body to simulate physically, including the arms, but then the head would just like stay static. And that would let you have only one dynamic bone component, which, like I mentioned, it goes all the way down the joint hierarchy. Even if there's a split, it just goes all the way down through the different children. Let me find one where that's used. I think the sombrero is one that uses that. Okay, yeah, so you can see the sombrero is only 7 joints, and it's kind of like a Y shape. And it goes down to the back and then up to the sides, and I just define the one parent joint, and then automatically dynamic bone goes through all three directions of children, if that makes sense. All 3 directions of the joint split. But if I wanted to like not make the back flop, then I could mark 5 as an exclusion, and that would make only the front 2 flop. Controller came unplugged. Sick. Yep, and that's cool. It's a cool aspect of it. Some stuff we skipped. End length and offset I haven't really messed with too much, so I don't want to pretend that I know what those do. Looks pretty weird. Gravity does what you expect. It adds like a certain amount of offset every frame. The interesting thing about gravity in this asset, which I don't really understand yet, is it only seems to add this gravity while you're moving. It doesn't, once you return to your main position, it doesn't continue to apply the gravity. So this is just like an additive thing while you're moving, which makes it a little unintuitive to use. Other one is force. Force, unlike gravity, is used all the time. And these numbers have to be pretty small. You can see I'm working with like 0.02. That's pretty goofy. Let me, got some bro joint. Excuse my voice being a little hoarse. I was at Bit Bash yesterday and just like, basically just like shouting the whole day. So that's kind of all I have to say about Dynamic Bone. It's pretty sweet and I'm using it a lot. I highly recommend it. it's only $20. Like, even if you don't end up using it in your project, it's still fun to play around with, and you can make some cool stuff with it. Let's move on to the next thing on my list, which is optimization. Fun stuff. Yeah, I'm optimizing for my target platform, trying to get up to 60 FPS if possible. At worst, I'm going to target 30 FPS when I'm in 6 or more player mode, and then beneath that will be 60 FPS. So, talking about optimization, I mentioned earlier when I was talking about when I ran into that hat issue, I mentioned that in Unity, when you have a big hierarchy of stuff, when there's a lot of things that are childed to your thing. Just looking at Scout has a pretty deep hierarchy of stuff. These are all hats. You can also see a lot of this stuff is disabled, inactive. Inactive's the correct Unity word. And what I expected, and what a lot of my Unity developer friends expected when I mentioned this to them, is that inactive objects like this, like all of these hats, of which there are a lot, which there are 60, not all of them have a ton of children, but all of them are inactive. What I expected is if I moved my scout, if I moved my player, I would not expect that those hats would give me like I would not expect them to take up CPU time to have their positions updated, because they're not active and they don't need to be rendered, and their components don't need to be ticked, so I'd expect no cost. But actually, there's totally a cost. Looking at chat, Spastic Chihuahua, there's one console that the game is coming to at launch, and I haven't announced it yet. It will be announced at the end of this month, but that will be at launch this fall. And PC and Mac, I should say, on Steam. Welcome, Fudge. Going back to this performance thing, so I didn't expect updating the positions of all these inactive hats to take any time. I expected it to just be like a lazy kind of update where once they're set active, then I would like go through the transform hierarchy of all these like player, hip, spine, etc., get down to the hat, and I would do all that matrix multiplication and like take the local position and get the position. But actually in Unity, you do take a performance hit for all that, or CPU hit for updating all of these things, even if they're inactive. So my solution to that, when I hit play, was I take all of my hats and I put them under a separate game object that doesn't get moved, and I call that a hat cache. I can show you that in the scene, and that's at the that's under the same child as my player. Yeah, so that's separate. So when the player gets moved, that doesn't affect the hat cache. It doesn't need to update all of the children because it's separate. And when the player wants to switch hats, it just takes the hat it's wearing, puts it under the hat cache, grabs the one it wants from the hat cache, puts it on the player, and so it only, at worst, it adds like five or six joints to the player's hierarchy. That's useful. Right, Singing Kappa, you could, when I go to read position, I could calculate it then. Like that would be what I expect, is that the position would be a property, and it would, when it gets in there, it would say, is this active or is it inactive? If it's inactive, then check some flag that's like, has my position been updated since have my my matrices been multiplied since I was set inactive or since I was moved. If it hasn't, then do it and return the position. But it's not like that yet. I've heard that Unity's working on that, but I haven't seen it. Shoddy, I did design all the characters. Can't see them there, but over the last year and a half, I modeled all of them, designed all of them. They're pretty silly. If you've seen any of the promo art, that art wasn't me. That was Storm Neep, who goes by Imploding Oracle on Twitter. They did a super great job of drawing like very cartoony 2D dudes. And then Great Davenport, welcome, dude. You can change the hats in the middle of the game with one of these hat carts, and that lets you just walk up, change your thing, change to this chicken hat. And the hat card is going to be in the Overworld, and I think it's also going to be in all of the arenas, so it'll like, you'll be able to do that as you go. Let's do that. So yeah, you can do that. Let me get back to my optimization list. I think that's enough about the transform hierarchies. Another thing I want to talk about that's kind of a funny story, but brings up a useful optimization tip you may have heard already. Let's do one NPC. So until recently, and to some extent still, coins mode is the least optimized game mode in the game. And in this mode, you fight, which knocks out coins. And by dashing and stomping near each other, you can knock coins out, collect them. As you can see, there's potential for a lot of coins to be spawned in the arena at once, like upwards of 50 sometimes. And that adds, these are physics objects, so it just adds a ton of stuff to the scene. And so that was like tanking my frame rate. And so I was trying to optimize this and see what was going on, and I eventually noticed that the expensive part of these coins wasn't it was like the physics part of the coins was expensive, but it was actually the spawning and despawning of the coins. I was destroying and instantiating, and I thought I had fixed that because I used object pooling, which I'll talk about in a second, to not actually be instantiating coins every time, but instead what object pooling is you have in the scene, you have basically a big list of game objects that you pre-spawn at the beginning of the scene that you draw on. Let me find this object pool. Okay, so I have this object pool, which is in the inspector. You can see I have a bunch of different game objects, that I define and say at the start of every scene, I want to like ensure that I have these objects pooled so that I don't have to be instantiating them, because I'm potentially going to be instantiating a lot of them. Previously, when I came into this to check on the coins to see what the heck, why are my coins being instantiated and destroyed every time, you know, the cloud drops one or hits somebody, I came in here and the one that said 100 here, my coin thing said it wasn't none, but it was like missing game object, which happened a few weeks ago when I redesigned the coin like model. I hadn't correctly like linked up, I hadn't replaced the prefab correctly the previous time in all the places where the coin prefab was referenced. So I came in here and saw, oh no, I broke the coin object pooling, and that was a big part of what was causing my frame rate tank. Is every time a new coin was being created, it was just like, you know, instantiating it from nothing, which is much more expensive than like grabbing one from this list of deactivated game objects. So that's a big optimization thing you can do is to, instead of spawning, instantiating at runtime all of your objects, you can pre-instantiate them at the start of the scene, put them in a pool, and just like grab them from this pool when you need them. And when they get destroyed, they go back into the pool. To manage object pooling, I'm using an object pool that Chevy Ray wrote years ago, I'm pretty sure. If anybody remembers the old EVD Patterns website, I don't think it's still up. Maybe it is though. Yeah, no, it's down. That is unfortunate. Oh, check that out. I'll link what I have. It looks like all of the Unity patterns got uploaded to GitHub, all the code there, so you can still get the object pool that I use. To give you a little background, Unity Patterns was this website that Chevy Ray, who's like a really cool game developer making. Oh man, I should look up his game if I'm gonna mention him. He's working on a game called Eichenfell, which is like a 2D RPG with like interesting fighting and cool magic. I'll just link his Twitter. You should follow him if you aren't already. Anyway, many years ago, like 5 years ago, he ran this site called Unity Patterns that whenever he discovered some new cool Unity thing or wrote like a cool, useful Unity thing, he would upload it to the site and kind of write a post about it explaining how it worked and why it worked. And it was really useful in me learning how to use Unity and learning C# in general. And his object pooling is still, even though it's probably 4 years old at this point, I still use it for my game. So check that out. So that's object pooling. As I mentioned on Twitter a couple weeks ago, null checking is really expensive on the platform I'm developing for, my like target console platform. And this is the idea that in a frame you might check like, is my reference to a certain player still valid, or have I destroyed that player? And I might check that before I move the player or respawn the player or kill the player. And there's so many uses for this. There's so many times I use this every frame, or this kind of thing, and to discover that this is like really slow on my target platform is tough. Like I had to go through my entire project and basically like, I wouldn't say I've gotten rid of all of them yet even, but I had to get rid of as many as I could uses of this null check thing. And this week I went through and did even more, and one big one that I did is in my Singleton class. And so, sorry to make this like pretty technical. I imagine a lot of you watching aren't programmers, or haven't been programming very long, and so some of this might be too technical. But I'll try to like get through it quick. A singleton is a design pattern that a lot of programmers use, and the use case of it is I have one thing in my game that I want to reference in a lot of different places, but I don't want to have to, every time I write a new script, I don't want to have to like give a specific reference to this thing and like cache, like find it in the scene and then get a reference to it. So instead of doing that, I just like make it static, which basically makes it a global reference to this one thing. Then I can, in code, I can just say, I can just grab it and use it and just forget about it. An example of this is the player manager in Sausage Sports Club, which is a singleton that I use to spawn players. I use it to get a reference to all the player data. I use it to get a reference to all the spawned players in the scene. I cache at the start of the game. I cache all the prefabs of all the different types of players, and I use it to cache all the different like skin information and stuff like that. And all of this stuff is used all over the game, and I feel like it's, when I write code, I don't want to have to be constantly like, every time I write a new script or every time I decide I need to reference some player data, I don't want to have to like find the object that has it and cache it, and I don't want to do that stuff, so I make it a singleton. There's a little bit of boilerplate you have to do to write a singleton of basically like I said, having this static reference to it that you save so that you can access it anywhere. And this is my like templated singleton where I implement all the boilerplate so that when I write a new singleton, I don't have to do all this stuff. I just inherit from the singleton class, and that's all I have to do. In mine, I choose to throw an error if the singleton doesn't exist and I try to reference it, and that's just to like enforce that I'm writing good code and that I'm not mistakenly like forgetting to add my singleton to the game or whatever. So that's how I do it. But as I mentioned, when you have a singleton, the use case is generally so that you can reference one thing with a little boilerplate code in many places. And for something like my player manager, that's potentially in like 30 different scripts. And it might be one time in a script, or it might be 10 times in a script. And previously, remember I talked about null checks and how it's expensive. Previously, anytime I was referencing the player manager, I would first do a null check to ensure like, is this thing ready? Is this thing like safe to use yet? Does it exist? If it is, then I will use it. And you can see that here. I've fixed the expensive part of this issue by replacing my null check with a bool check or a flag check. You can see I have this flag has instance, which when I first get my instance, when I first find the object, I set, or if I fail to find the object, then I also set has instance to false, and then I would throw an error. But now I'm not like checking my reference to this object and checking if that's null, which internally is apparently an expensive operation on this platform I'm developing for. So I switched to flags, and it was pretty simple to do. I just have to like once I get my reference, save the flag as whether the reference is valid or not. So this is one null check instead of dozens. Whenever I reference this singleton, that would be another null check. And then the other thing that I had to do that was really important that I forgot to do originally is when I destroy the singleton, I have to set it false, or I have to set this flag false. Because this flag is static, if I create a singleton and then destroy it and then create it again later, that flag is still set because it's static, it's global, it's like it's one per type rather than one per instance, which is normally how programming works, or normally how object-oriented programming works, I should say. So the way this bit me was in the paint mode in Sausage Sports Club. I had a singleton called Paint Manager, which held data about the entire paint mode. Basically, like all of the like textures where I draw the paint stuff and what color each team's paint should be and all this stuff. I don't get too much into that, but I I had this paint manager, which was a singleton, which was created when you enter paint mode, and then when you leave paint mode, it was destroyed. But that singleton's has instance flag wasn't being reset because I forgot to reset it on destroy. And then when I would go back into paint mode, and I would try to first reference, the paint manager, I would get into this, and it would check, is the flag set to false? Does that, which basically means, do I have to find the singleton again? And it would say, nope, we're good, we have it. And then I would try to return the instance, which had been set to null because we destroyed the paint manager. And I would get tons of errors from this when I would try to reference a thing that didn't exist. Welcome, Zarim and Indiana Dixon. So that's going to be the end of my like very technical singleton rant. But in case you end up on a platform where null checks are inefficient, now you know. Zarim and Bitbash was really fun. It was I would say it held up to all the other Bitbashes. It was really cool. It was a new kind of Bitbash for me because my game wasn't there, this was the first year where I didn't have any kind of game where I felt like huge ownership over it. So it was kind of it was more like a hang out and party and like talk to people I knew already kind of thing, rather than a pitch my game or like get feedback on my game or take notes on playtesting and stuff. So it was fun. A lot of really cool games. I played one thing I remember that surprised me with how cool its mechanics were, was Wibble Wobble, which is made by Daniel Linson, and it's the version of Bitbash is like co-op, and so you're like cooperating to get a high score, but the game, and I'll link it. Whoop. Wibble Wobble, Daniel Linson. I'm actually gonna have to kind of speed through the rest of this stuff. Here's that. Yeah, so this game was really cool. It had this interesting co-op mode where you can bounce off of other players, and that lets you like jump higher to get the stars, which is like the currency in the game, more easily. And in the game you also die when you hit anything red, but your player sticks around on screen, and if I bounce off of a player who's dead, then they come back to life. So it has like an interesting like dual mechanic of like bouncing, and also you can revive your friends that way. And it was a hoot. There were other cool games, but I'm gonna stick to talking about Sausage for now. Indiana Dixon. This is the same office that was covered in that Chicago game scene documentary. Indie City Co-op. It's a big part of the Chicago indie scene, I would say, and it's really cool to work here. All the people here are really smart and working on cool stuff, so that's fun. I'm gonna turn on the lights. It's getting dark in the office, so give me 1 second. Okay, I'm back. Now we're going to talk about the profiler. First, I'm going to choke on water. Then we're going to talk about the profiler. Ugh. Okay. Let's do profiler. So a couple days ago, I commented out all my profiler tags, or all my sample tags, and now I want them to not be gone. profiler. Okay, that's good. There's a few places where this is gonna break the game, I think. Or it's gonna break the... I don't want to get into how it's gonna mess things up. Okay, so let me give a little background on this before I talk about specifics. So when you make a game, often you will get really deep into it, get close to launch maybe, and you haven't thought about optimization. This happens in a lot of early access games where you play. It's not that complex of a game, but it runs really crappy on your computer, and then they get close to launch, and suddenly the game runs amazingly. They realize there's a ton of easy wins that they could get that they just hadn't been working on. When you go to do this in a game, there's tools built into a lot of game engines to help you figure out what's taking a long time, what's eating up a lot of your memory, what's killing your GPU, kind of stuff. I think that I'm not going to be able to focus on this problem while I talk about this. So let's just skip over to this. So in Unity, the tool, or one of the tools that you get, is the profiler. And the profiler looks like this. The profiler has a few aspects. The one I use the most is CPU usage. And as you're playing, you can hit record, and it'll just start. Every frame, it'll record how long things take to happen in your game, and then it'll spit it to this window at the bottom and give you a bunch of data. Because I just enabled a bunch of tags, I'm gonna play the game for a second just to get some data. This tool is extremely useful in debugging why your game runs slowly, especially on low-end platforms. That should be plenty. Okay, so we've got this jittery mess of green and blue and orange and purple. So what's all this stuff? If we click on it, like I said, and look at the bottom here, we can see a bunch of different things. We've got rendering, which is green. We've got some orange, which is physics, and some blue, which is code. Code I write is going to be blue, generally. Some different stuff, and we can open these up and it'll get into specifics of what's taking time, and that might be code that I wrote, that might be a plugin like Fabric, or in control, which is just input. And look at that. That's cool. So let's look at the columns. There's total, which is a % of the entire frame that specific group or specific thing took. Looking here, you can see there's CPU 5.10 milliseconds. That's how long the entire frame took of the game. And 5.1 milliseconds is really fast. That's, as you can see here, that's 250 milliseconds. Not sure what self means. That's weird. Calls is how many calls made that up. How many times that thing happened. scale tween. Apparently 14 scale tweens were called this frame, which is, scale tween is a component that I use to like make things like tween up and down, or mostly up and down. But sometimes if I'm doing a transition, like if a window, if a like UI panel is like tweening in, I might want it to like start small and scale up, and that's what that would be used for. And I guess there were 14 going on in that frame. GC alloc, that's garbage collector in C#. The C# as a language has a feature called garbage collector, which automatically grabs any memory that you have allocated but isn't being used anymore by your game, and it just like automatically gets rid of it and adds that memory back to the pool of available memory. To a lot of people, this is like the thing that makes them not want to use C#. And it does make the language run a lot slower than something like C++. But it allows users to not have to manage their own memory. Take it if you want it. This isn't going to be a programming. I'm not going to have a debate about programming or like get deep into that. But that's what this column is. And if something allocates a lot of memory, then it is usually pretty expensive. Let's see if we can find anything that's really expensive. 0.5 kilobytes. That's not that much. At this point, I've probably done a pretty good job of optimizing garbage collection. What do we got? Okay, 1.2 kilobytes. What do we got? Physics. And I don't know what caused that. Anyway, and then time is milliseconds, which, you know, is a useful metric. If something takes, like if my game is taking 100 milliseconds for the frame, and I see something's taking 90 milliseconds, that's probably something like a good thing to optimize. And so this is kind of how I go about doing optimization. It's a little hard to show you an example because I've done a lot of it already, and my computer's really fast, and I would be optimizing on my target platform generally rather than the computer, since my computer is going to just like do everything 100 times faster than the target platform. But to give you an example of how I might approach this problem of optimization, I would look for some like weird spikes in this line of CPU usage here. So like this one's weird, and then I would organize by time in milliseconds, and I see it looks like my camera isn't the thing that's taking a long time. It looks like there's a spike in physics, and that looks to be the main spike. So let's look at physics processing. Is that the big spike? Physics processing. Looks like physics processing is the big spike. So we go into that, and then we look at all this stuff. And this often in physics is a big problem. That's like not necessarily something in my code. That's usually something that I've set up strangely in the scene. Maybe there's too many physics objects. Maybe there's a trigger that's too big, so it's like hitting everything. And maybe my physics layers aren't set up correctly, so things like my player are colliding with something they don't need to be. Like maybe they're colliding with UI, which doesn't make any sense. So what is this? Physics context manager discrete update. I don't know what that means. It sounds maybe like hold on, I have to sneeze. It sounds like maybe a bunch of things are contacting at once, and that's like, and so that update is like has to run through more colliders hitting each other than normal. Not sure. Let's try to find one that's not a physics spike. Here looks to be a blue spike. Okay, so yeah, this is a blue spike. It's causing our spike. Kind of seems like it's not behavior update. Yeah, it looks like fixed behavior updates a little bit. You can see here it's a little bit taller than the rest of them, so let's look into that. See what's up. Player physics, what's going on here? Physics state. So when I mentioned before, in code I commented out my profiler samples. Now that we have a background of what the profiler does and how it's used, we can get a little bit more specific. So in my code, if I want to debug a specific chunk of code, Unity lets you define what looks like this. It's a sample, and I can say, and I wrap a chunk of code in profiler begin sample and then in profiler end sample, and that tells the profiler, hey, look at this chunk of code and here's what its name is. I want you to show me that in the profiler. So this, I'm not going to see, I don't think I'll see soccer state. But physics state is one, ground state is a sample that I defined. So all of these move sausage, that's something I defined. So you can see ground state took 20 milliseconds, and of that 20 milliseconds, handle movement took 6 milliseconds. Check is grounded took 5, so it's 11. 2 more, 3 more, so that's up to 14. So then there's some stuff that doesn't really, like, these numbers don't add up to 20, which means I didn't cover everything in samples. So this in this type of situation, this is when I would say, okay, I need to go look in grounded state and see where did I not put specific samples. There's 6 milliseconds there that's unaccounted for that I don't know where that time is going. So I'll do this here. I'm not going to get too deep into it, but I'll do a start just so you can see what this looks like. So we're in ground state here. We can see, and I'll do like a side by side. How do I want to do this? Put it down here. Okay, so you can see ground state. So we've got ground state that took 20 milliseconds. We've got 6, 5, 2, 1, which is 14. So we got 14 milliseconds. So there's 6 unaccounted for. Where did that go? We've got should be grounded, which covers here to here. And then you see there's no sample for a while, all the way through here. So potentially this stuff could be taking, let's put one in. Profiler begin sample. And this stuff is checking. Okay, interesting. So we've got, so what's happening here is there's a few conditions I check before I shoot a raycast, check if we're grounded or not, and this is an optimization in itself. Basically, like shooting lines towards the ground to see if we're on the ground is an expensive operation. It takes a lot of CPU time. So rather than doing that all the time, I do some checks beforehand to try to like skip it. One thing I do is I only I have 8 players. Instead of having all 8 players cast these rays every frame, I say even numbered players, like player 0, 2, 4, 0, 2, 4, 6. Is that right? 0, 2, yeah, that's right. 0, 2, 4, 6, you're only going to check on even frames, and then players 1, 3, 5, 7 only check on odd frames. So that splits it in half. And that's useful. And that makes it 50% fewer raids. So let's do check for even frame / even player. Then I'll put this here. This is the bottom profiler and sample. So that's one. And I wanna just for our example, I wanna just cover all of this grounded state thing. So movement, handle movement, as we can see over here, I already have that wrapped. That's already a thing that I'm sampling. Gravity check, doing it. Sausage move, also covered. You can see move sausage here. Changing state isn't covered, and then so our base is covered. So some things that we can see aren't covered. These checks of if we have control of the bottom of our character, if we have control of the top of our character, if checking if we're grounded, which I believe is just checking a bool, checking 2 bools. Yeah, that shouldn't be taking up any time. So let's do a couple more. I would be surprised if these are taking up that other 4 milliseconds, but I'm not really sure what else could be. I'm gonna do this. I'll just do has bottom control, and then we'll see. It's kind of a bad name because it's not really describing the branch that's happening here, but profiler and sample. Begin sample. Just so everybody knows, I'm gonna have to leave in like 15-20 minutes. Turn on my phone. Okay. So now I have to record again and just we'll have to skim through the profiler again. I'll make this quick. This will be the last thing I talk about optimization right now. I'm probably going to cover it again in future weeks since I'm going to have to do more optimization. Okay, let's call that recorded. Let's look for fixed update, fixed behavior update. Okay, that one's a spike. Player physics, physics state, ground state. Interesting. So that's taking up. Okay, so that's not taking up much. It's mostly the internal check is grounded. It's taking up time. So that's interesting. Has bottom control is actually taking up an entire millisecond. And so it has top control. So what's even happening there? Full control lens. So this is a whole thing. I don't want to get into this. Operator T. Implicit operator T. Cast result. So how do I get this cast result? Operator T. So it's a bool. That's really interesting. It's interesting that this is taking 1 full millisecond because all I'm doing from what I'm seeing, what I think I'm doing is I'm for these two objects, which is a custom type that I use, I'm going into them and I'm using a custom operator which casts to a bool, but because it's which casts to a bool, and then inside that function I'm just returning like a local bool. An interesting aspect of this is that this is a templated class or generic in C#, and so it's casting, or it's this implicit operator is returning a generic bool, and the value it's returning is also a generic bool. So maybe generics are slower than, I mean, I'm sure they're slower than a normal bool would be, but this is an interesting thing to find, that this is taking a whole millisecond, or like most of a millisecond, since the profiler's not gonna like tell us this is taking 0.85 millisecond or 0.085 milliseconds. Sorry, I realize I've been saying this is taking a whole millisecond when it's only been taking 0.01, so 1/100th of a millisecond. But it's interesting that it would even be taking that much time, because it's just returning a bool from a function. Okay. Anyway, I want to move off of optimization, but that's been like an overview of how Unity's profiler works and how you use Unity's profiler. I hope that is useful to you. If you ask me, I'll probably be willing to talk more about profiling later, and I can get into specific questions later. Last thing I want to cover, which I'm going to kind of rush over. Let's close that. Is convention stuff, convention feedback. So like I mentioned, I was at BitBash yesterday, and if you don't know, BitBash is Chicago's premier game festival, which was kind of started to show the larger community in Chicago, and just like in the world, I guess, to show that games are art and games are a medium, and that there's a lot of different kind of games, and to bring games that aren't Call of Duty or shooty killy games, trying to bring that type of game to a wider audience and to show that games are more than those. I'm sure you know people who think of games as only that, and they aren't only that. So that's what BitBash is. I volunteered this event, and I was setting up yesterday, and I set up a bunch of games, and when you set them up, you kind of test a little bit that they're working, and a lot of them I would notice some weird things. And I'm not going to point any specific ones out, but I do want to point out some tips that I had based on that experience and based on the experiences of bringing Sausage Sports Club to a bunch of different conventions over the last year, or year and a half, I guess, at this point. So some things I want to recommend, and this I covered this on Twitter, but I'll try to jump around in Sausage to show you what I have for these. So first is autoplay, and this is a really important thing that took me a very long time at shows before I realized this was so important. But now I wouldn't go to a convention without this. And this is because when your game is being played and somebody finishes playing and they walk away, what's going to happen in my game is it's going to just be like let's do 2 seconds. It's just going to be like an empty arena, no movement, like character standing still. It's unclear what the game is because no one's playing it, and it's not going to reset itself until somebody comes back. That was weird. Let's get rid of that. So what you can do instead is you can either switch to playing a video of people playing your game, or That's probably the easiest thing because it's really easy to record a video. That's weird. Or you can, if you have AI in your game, you can switch to the game playing itself, which is what this is. And this is what I have at conventions, because people walk up and they see the name of the game, they see press any button to play, they see the game being played, and they can kind of discern like, oh, this is about silly animals. It's kind of a platformer. It's kind of cute, fun, silly. You know, they get a vibe for the game, and the other benefit this has is that the game is restarted once they start playing. Then they like get the menu and they can actually get into it. They can figure it out. So that's a big one. Next one, controller, mouse, and keyboard. At BitBash, I noticed there were a few games that had kind of a weird menu flow of like I have to like click around menus with my mouse, and then once I get into the game, it's all controller. Or like there was one game there that was all usable with the controller until you got into the game, and then there's no way to go back to the menu from in the game unless you finished a round and like went back to the menu. So if players got bored in the middle of a match, or if they had to go run and do something, or if somebody's controller came unplugged, or if another friend came up and wanted to join mid-game, there was no way to do that. They had to just wait until the end of the game, which more often than not is just instead going to be, oh, we're just going to leave and go to another game. We don't want to wait for this. That's too much of an inconvenience. So I recommend you make your entire game flow work with a controller, or if your game is a mouse keyboard game, make the entire thing work with a mouse keyboard, which is obvious. A lot of game conventions like BitBash prefer to use a controller, so if it seems like your game should work with a controller, they might just like stick your controller there, and then if there's got to be a mouse and keyboard, then you might just be screwed, or I don't know. Semi-related is mid-game drop-in. Turn off track mode. Turn off skip menu. So this is the idea that in the middle of a match, if you have bots in your game, somebody else can come up and start playing immediately. They don't have to wait until the game's over. So for me, this was super simple. So I've got these bots, and it's going to be kind of hard to tell, but they just follow me around as their behavior right now. If I hit space, this shark is now my keyboard. And that works in the game. If somebody walks up and there's a fourth controller and there's a fourth bot player, then you just take over the bot. And that's super, super useful. I really like this dove, or this pigeon with emo hair. I hadn't seen that. Pretty goofy. So that one's pretty good. Pretty useful. It's pretty easy to do also. For me, it was just when you hit in my AI script, in my update loop, I check if some controller has hit a button and that controller is not assigned to another player, then take over this bot. And taking over this bot means delete my AI script, add a player script, assign that input to the player script, and that's all I have to do. That's pretty simple. So that's pretty easy, pretty big deal. INI settings. Okay, this one's I can't really get into too much detail of how this works right now because I have to leave very soon. But Steam. I do want to show you the file just to show you what this looks like. Then I might have to run real quick. Trying to find Steam apps, Common, Sausage Sports Club. Where's my INI file? I don't really have time to make a build right now. That sucks. If I think sausage is gonna open, probably over the screen. This looks good. Is this what's on Steam right now? That would suck. Hope that doesn't happen again. Well, I'm gonna have to deal with that, I guess. But not right now. Okay, so this is the INI file. I don't know what INI file stands for, but it's been around in games for a long time. You'll often see like people switching their like graphic settings with INI files. And I'll eventually do that, but that's not what's going on here. So this file is just like settings that are exposed to a file, and when the game opens, it loads all of these files and sets debug settings for this stuff. And what's really cool about this is at a convention like BitBash, instead of having a setting in the menu where every time the app opens, some volunteer or some savvy player has to like go find these settings, you can set them manually in this file when you set up the game, and then these settings will always be used. So like attract mode, for example, I set attract mode true. Now attract mode, as I showed you before, is on. It doesn't have to be enabled in the menu if the game crashes or something. Similarly, if you want to make games last 10 times as long, I don't know why you'd want this, but that's in here too. And this is really useful. Like, it's, if let's say I'm at a show and I want to test a bunch of different settings, like what the most fun length of a match is, I can change this between game rounds, and it's not gonna like get in the way of the game. I don't have to take your controller away from a player. I just have to say, hey, give me 1 second, I'm gonna change something, and it takes literally 5 seconds to open this file, change that number, and then open the app again. As opposed to making an entirely new build, which, you know, takes like 10 minutes depending on how big your game is. So yeah. Looks like my thing that I'm going to has been delayed a little bit, so I'll probably actually be on time instead of late from this stream. So yeah, the INI thing is cool. It's really useful. It's pretty easy to set up. It's just loading a file, which you probably have to learn to do to make a game anyway, if you're doing like saving or anything like that. That's all I have to share today, actually. That's all I wanted to focus on. So if anyone's got questions, I got just a couple more minutes. That's kind of all I want to show. I'm gonna call it end of the thing there. I'll hang out for another minute for questions if there are any. Otherwise, I'm not gonna work after the stream. I'm just gonna get out of here. All right, looks like no questions, so I'm just gonna call it here. Thanks for hanging out, everybody. See you next week.